Realbotics just built a humanoid robot that recognizes your face, remembers your past conversations, and reads your emotions in real time. UniX AI's Panther is already cooking, cleaning, and running homes for up to 16 hours on a single charge. IHMC's Alex is built for war zones and disaster sites, moving faster and handling dangerous environments before humans step in. At the same time, Princeton created a robot that moves using heat instead of motors. Scientists built living neurobots with real neurons, and new artificial muscles now let robots lift up to 100 times their own weight. And now Unitree is about to launch a $4,000 humanoid globally. All of this is happening right now, so let's talk about it. All right, so a company called Realbotics just delivered its first humanoid robot equipped with a system called Vinci to Ericsson. And the whole point of Vinci is visual awareness combined with memory and behavior tracking. Now, what makes it different is the way it actually interacts with people. The cameras are built directly inside the robot's eyes, so when it looks at you, it's not fake eye contact. It's actually tracking your face, your movement, and your behavior in real time. That alone changes how natural the interaction feels. Now add memory on top of that. The robot can recognize returning users, remember past conversations, and continue where things left off. So instead of resetting every time like most assistants today, it builds context over time. That's a completely different type of interaction loop. It also tracks emotional signals, which means it's analyzing how you respond, your expressions, your engagement level, and adjusting its behavior accordingly. So the interaction becomes more fluid and personalized instead of scripted. Under the hood, it's doing object recognition, motion detection, and real-time engagement tracking. And the key part here is not just interaction, it's data. Vinci is designed to capture structured data about every interaction: who you are, how you behave, how you respond emotionally, how engaged you are over time. That data can then be analyzed by companies. So this becomes a tool for customer engagement analytics, training environments, even clinical research. You're basically turning human-robot interaction into measurable datasets. And it's not locked to one robot. Realbotics says Vinci can be integrated into all of their humanoid platforms, which means this system could scale across industries pretty fast. Ericsson deploying it is actually a big signal. That's not a lab test anymore. That's enterprise-level use, where robots are interacting with real people and generating real data. Now, at the same time, a Chinese company called UniX AI launched a humanoid robot called Panther, and they're already shipping it globally. This one is designed for actual household use. Panther is about 5 feet 3 inches tall, weighs around 80 kilograms or 180 pounds, and runs for anywhere between 8 and 16 hours on a single charge. That battery range alone is already pushing it closer to something you could actually use daily. The design is interesting because it's not a traditional walking humanoid. It's wheeled, with a 4-wheel steering and 4-wheel drive system. That makes it more stable and efficient indoors, especially in cluttered environments where legged robots still struggle. It has 34 degrees of freedom, including something they call the first mass-produced 8DOF bionic arms. Those arms, combined with adaptive, intelligent grippers, give it pretty high precision when handling objects. And it's not doing single tasks. That's the key difference here. Panther is built for multi-step workflows. So it can wake you up, prepare breakfast, clean the kitchen afterward, organize the living space, and basically chain all of that into one continuous sequence. That's a big jump from robots that can only execute isolated commands. It uses a full stack of systems to make that work. Uniflex handles task generalization and imitation learning, meaning it can adapt across different scenarios. Unitouch adds visuo-tactile capabilities, so it can actually handle objects more precisely. And UniCortex is responsible for long-term planning, which is what enables those multi-step task sequences. It also has cameras, sensors, and audio systems for navigation, object recognition, and interaction with people. And the use cases go beyond just homes. They're targeting hotels, retail, reception services, guided tours, elderly care, even industrial environments like security patrols and research. There are still challenges, of course. Real homes are messy, lighting changes constantly, soft objects are hard to manipulate, and reliability is still a big question. Battery life, safety, cost, all of that still needs to improve. Still, The fact that these robots are already performing multiple real-world tasks in actual homes is a pretty clear shift. And that same problem shows up in AI video too. The moment scenes get messy, dynamic, or harder to control, most models start falling apart. Higgsfield is sponsoring today's video, and what they're building with Cadence 2 plus Claude is basically a full content pipeline in one system. On its own, Claude is one of the strongest models for reasoning, writing, trend analysis, and structuring ideas. The problem is, it cannot actually generate video. That's where Cadence 2 comes in. On Higgsfield, Claude can feed directly into Cadence, so the intelligence side and the production side connect inside one workflow. Instead of using separate tools for scripting, ideation, video, and audio, the whole process runs through one pipeline. Claude handles the thinking, narrative, structure, audience fit, and positioning. Cadence 2 handles the output, cinematic video, character consistency, complex motion, and native audio. And that is the bigger shift here. This stops feeling like two separate tools and starts feeling like a production system. No bouncing between tabs, no copy-pasting across apps, no awkward handoff between the smart model and the model that actually makes the content. Once that loop is working, you stop thinking about one post at a time and start thinking in terms of scale. So instead of chasing one viral clip, you are building a system that can continuously produce content. Try Cadence 2 on Higgsfield with Claude. Link is in the description. All right, now let's get back to this. Now, while some companies are focusing on homes and interaction, others are pushing into extreme environments. There's a humanoid robot called Alex, developed by IHMC in the US, with support from the Office of Naval Research. This one is built for situations where humans shouldn't go. Alex is the successor to a robot called Nadia, which was already known for things like playing ping pong and boxing. The new version focuses more on real-world mobility, autonomy, and response speed. One of the biggest upgrades is weight reduction. Alex weighs about 187 pounds, including its battery, down from Nadia's 220 pounds. That might not sound massive, though in robotics, that kind of reduction has a huge impact on agility and energy efficiency. It uses custom high-powered actuators that cut weight without giving up strength, which is a big deal for a robot like this. That lighter build should help Alex move with more speed, react faster, recover balance more smoothly, and handle unstable terrain with a lot more confidence. On the hardware side, it comes with 19 degrees of freedom, high-speed joints that can hit 9 radians per second, and wrists with up to 300 degrees of motion. All of that gives it the kind of range, agility, and control it needs to deal with more demanding, complex tasks in the real world. It can also carry a continuous payload of about 10 kilograms, which makes it a serious candidate for work in collapsed buildings, hazardous environments, disaster zones, and even military-style operations where strength, precision, and mobility all matter at the same time. The idea is that it operates as part of a human-machine team. It can go into dangerous areas first, explore, gather information, and reduce risk before humans step in. Interestingly, Alex doesn't even have a face yet. At its public debut, people are actually going to design its face, and the best designs will be turned into real models. That's kind of a reminder that the focus here isn't appearance, it's capability, balance, perception, autonomy, and real-world performance. And the same system could be used in manufacturing, logistics, aircraft maintenance, oil rigs, basically anywhere that requires precision in risky environments. Now, if you zoom out a bit, you start to see something else happening in the hardware itself. Researchers at Princeton just built a robot that doesn't use motors at all. Instead, it moves using heat. They used a material called liquid crystal elastomer, which can be programmed at the molecular level. When heat is applied, the material contracts or bends in specific ways depending on how it was printed. So instead of building a robot and then adding joints and motors, they're embedding movement directly into the material itself. They used a custom 3D printer to create patterned zones inside the material, and these zones act like hinges. When heated, they bend predictably, allowing the structure to fold and unfold. They even integrated flexible circuit boards during the printing process, so everything is built as one system instead of being assembled afterward. The robot includes temperature sensors and closed-loop control, meaning it can adjust itself in real time to maintain accuracy over repeated movements. They demonstrated it with an origami-inspired structure that flaps like a crane, and it does this repeatedly without noticeable wear. That's important because durability is usually a big problem with soft robots. The system also uses mathematical models from origami design to control motion. So this is not random bending, it's highly structured and programmable. The long-term idea is scalability. These robots could be manufactured more easily, operate in environments where rigid systems fail, and even be used inside the human body. Now, if that sounds advanced, the next one goes even further. Scientists have created what they call neurobots. These are living robots made from frog cells with actual neurons integrated into their structure. Previous versions, known as xenobots, could move using cilia, basically tiny hair-like structures. Though they didn't have any internal control system, neurobots changed that. Researchers inserted neural precursor cells into these biological constructs. Over time, those cells developed into neurons and formed networks inside the robot. Those neurons connect to other cells that control movement, which means the robot now has a basic nervous system influencing its behavior. And the effects are very clear. The robots become more active, their shapes change, and their movement patterns become more complex. They even tested how neural activity affects behavior by using drugs that alter neural communication. The results showed that the nervous system was actively shaping how the robots move. There were also unexpected changes at the genetic level. Some gene expressions linked to visual system development started appearing, which suggests that future versions could develop new sensory capabilities. That part is still early, though it shows how unpredictable this field is becoming. These robots are not mechanical. They're biological systems with programmable behavior. And the potential applications go into areas like medicine, where you could have living machines operating inside the body. Now, at the same time, there's another breakthrough happening in robotic strength. Scientists developed artificial muscles that allow robots to lift up to 100 times their own weight. These are called HARP actuators, and they're basically flexible, air-powered structures that mimic how real muscles work. Instead of rigid motors, they expand and contract using small amounts of air. That makes them lightweight, quiet, and highly adaptable. They can operate in extreme environments, including high heat and abrasive conditions. And because they're flexible, robots using these muscles can squeeze through tight spaces and move through debris. That makes them ideal for disaster response, where you need machines that can navigate collapsed structures without causing more damage. They've already built a robotic arm inspired by an elephant trunk, which can reach around obstacles with a high level of precision. There's also a wearable system that helps humans lift heavy objects by reducing strain, which shows this technology isn't limited to robots alone. And the materials used are strong enough for space applications, meaning these systems could eventually be used in space missions as well. Finally, there's one more shift happening that ties everything together, and that's cost and scale. Unitree is about to launch a humanoid robot called R1 globally, and it's priced at around 29,900 yuan, which is roughly $4,370. That's extremely low compared to most humanoid robots today. The R1 stands about 123 centimeters tall, weighs around 59 pounds, and is designed for dynamic movement. It can run downhill, perform cartwheels, stand up from the ground, and basically handle athletic motion. Unitree is planning to sell it through AliExpress, targeting markets like the US, Europe, Japan, and Singapore. And the scale is what really stands out. They shipped over 5,500 robots in 2025, while companies like Tesla, Figure AI, and Agility Robotics shipped around 150 each. For 2026, they're aiming for 10,000 to 20,000 units. That kind of production volume changes everything, because once you hit that scale, prices drop, accessibility increases, and adoption accelerates. Industry projections suggest Unitree could account for nearly half of all humanoid robot production soon. Anyway, that's where things are right now.